All right, y'all. We are back to our C++ learning. Where we left off last time was going through the notes for function overloading and templatizing functions. Now that we understand how templates work and default arguments within a function, I think we can, as a refresh, revisit this chapter summary. Just pulling up my notes on my notebook. And let's get started. Alright, so what is the output of this program? We have a print function that's taking in an int, then we have another one that's taking in a double, then we have a short that is being assigned an initialized list of 5, which will obviously convert to a short, and then I believe a short will default to an int. It definitely wouldn't default to a double, so I think it's either an int or a compilation error because of the short casting, but I think this would promote from a short to an int. Int5, converting a short to an int is a promotion, whereas converting a short to a double is a numeric conversion. Compiler will favor promotion over conversion. Makes sense. Why won't the following compile? We have a empty, no argument print statement. We have a print with a default argument. Then we have one with a double with no default argument. So this 5.0f will be fine. This would go to a double. This would be a promotion from a float to a double. And then the print on the second line, this one, line 21, this is the issue. Because both of these functions are in play here. So the call is ambiguous because we don't need to pass anything in because there's a default argument here. Yep. Why won't the following compile? Print long x, print double x. Print 5. This one's interesting because I don't think this is ambiguous. Let me just get to our directory really quick. Tree chapter 11. Oh, I know a tree in here. Anyways, okay, why wouldn't this compile? It doesn't match a type? I can see why double wouldn't work, but I don't. The literal is an int, converting int to a long or a double is a conversion. The compiler, oh, so, okay. Because they're both numeric conversions, not promotions, they're essentially the exact same. So it's, in layman's terms, it is ambiguous to some degree. Let me, this is better. It's a little better. Okay. Interesting. Very interesting. Write a function template named add that will take 2 arguments of the same type, and the following should return. Okay. Alright. Yeah, is this not the Q4 here? Function overloading? What's that? Oh, yeah, okay, this is where I wanted to leave off. Function overloading. Yep, template T, arguments of the same type. Okay, so we're good there. Write a function template named mult that allows the user to multiply one value of any type, first parameter, and an integer, second parameter. So the integer is, it'll always be an integer. So we will have template type name T. Second parameter should not be the function should return the same as the first parameter. So it will return this int y, and then we can do return x times y. And I don't think we need to typecast this, but we can. We know this will fail. Let's do mult y and x and see how this works. std 17 function overload. Yep. All right. Okay. And then just to confirm, t and then an int, we can just return it. Okay. Write a function named sub that allows the user to subtract two values of different types. Interesting. So the thought here is two templates, but so it would essentially be, we take this and then a type name u, and then we'd have t u x minus y, but then see, this is interesting. What would we use as the return argument? Do we need a third to resolve itself? Type name TUV. I need to do the alphabet. That's funny. Okay. Oh. Oh! Huh? Oh. Wait. I don't see the problem. Hang on. Let's look at that statement again. Is it because of this typing? Hang on. Okay, well, one point. See, this is my issue. Is it's either gonna take, like, I get why it would be an issue. Can you just do an auto? Can we just do auto of this? and then do a type name v. Invalid use of auto. Fair enough. Let's just make this auto. Whoa! What the? Oh. Okay, well, that's a lot. What did we mess up? Because if we're... Oh, we still have auto in here. Yeah, I can see why that wouldn't work. Okay, now do they use auto for it? Okay, they do. Okay, it wasn't specified, so I was a little confused. And is that the last? Okay, yeah, that's the last one to do like this. So we can add it, git commit -m templates and function types. Okay. Okay, what is the output of this program and why? We have a static int for a template for the parameter feeding into count. So these two will construct the int parameter count function with the compiler, and then this 2.3 defaults to a double, not a float in C++. So this will make a new function where count has the input parameter of a double, and then this last one is specifying the template parameter as a double, which means it should cast this as a double parameter. So these two are passing to the same function, and these two are passing to the same function. Now, so these will populate two different static int variables, which means their scope extends past the given function, and they're only initialized once when the function is initially called, and they stay until the end of scope. So with that in mind, if we're returning a pre-increment C, this will be 1, this will be 2, this will be 1, and this will be 2. Yep. And the only one I was curious about is this one. So when count cast double of 1 is called, the compiler will see that we're explicitly requesting the double version of count. This version already exists due to the prior statement, so we can call that and return the value of 2. What is the output of this program? So we have foo with int n, then we have a template that is returning n otherwise. So, okay. This is where I need to think a little bit about what the compiler is doing internally. So the compiler won't make... Will it make another? So, okay. What I'm thinking in my head right now is we have foo. If it's being told to the compiler that's looking for the int parameter being passed in, my thinking is if it's already in place here, it won't make another. So my thinking is this 1 will be 11. 2 is short, but I think the compiler favors a promotion rather than making a new instance. So I think this will be 12. So 11, 12, and then foo int 4. Huh. Okay, I'm gonna redo my answer. I think it'll make a new one. Because I was just thinking about it through my head. If you had a double and a float, those would be two separate. Those would be two separate functions when they're templatized. So I think this is 11. This is 2, making a new instance of foo, which passes in as short. And then foo int of 4 will default to here. So this will be 11, 2, 14. And then we're casting s to an int now, which means I think we will now do 12. So I think it goes 11, 2, 14, 12. And then if we have nothing here, if we have nothing in the specifier, then it'll go to the default type of the argument being passed in. And the implicit type of 6 is int. So I think the only one that doesn't add 10 is this one, is 2. And I am completely wrong. The only one that calls int is this. The rest that specify a different type or a template argument in the front of the function call all point, okay, they all point, so, okay. Case 1 matches food exactly, yes. Does not match, can't be converted to int. So foo is a candidate, however the compiler would prefer to use function template stencil at the exact match. Okay. Foo int is an explicit call to foo int, so foo foo template int. So foo passing in int isn't considered. Okay, it goes for that, and then syntax will only match function templates. Okay, got it. Makes sense. Before I get too ahead, something that I would like to get into is that yesterday I had an Apple interview, and I got a surprisingly easy question. This was for a verification role, but I got a fairly simple question. So I kind of just wanted to go over it really quick, because I kind of challenged myself choosing C++ because, yeah, I did C++ in work, but as you can tell, I didn't fully understand the language. So what I'm trying to do now is kind of like teach myself the language in total to get to a more cracked level, whatever that means. So this specific requirement was pretty much just designing a deck of cards. So we want to make a deck of cards. And essentially, I'm going to need to bring up the C++ vector because I need to understand there's all the references. Sure, the capacity. all I want are these. Okay. So I hesitated, in the interview, I hesitated from using a vector because I didn't know the specific APIs for the vector and thought I was going to mess up push back and pop. And I really shouldn't have done that. I think that was stupid on my part. I still got the answer, but I'll explain it in a second. So we want to make a deck of cards, 52 cards, 4 suits, 1 through 13 value, and color. So my first thought here was we'll make a struct for the card. It'll have a value. It'll have a string with the suit. And then I'll have another string for the color. And then it's actually, what I did is yes, that does make sense. Because I forgot the second part. We want to design a draw method to randomly draw a card and discard it from the pool of available cards. So obviously I could have used pop for a vector here, and then I just could have rebuilt the entire, once every card's gone, I could have rebuilt the constructor, or sorry, I could have rebuilt the whole vector of cards with a constructor. Definitely a slip up on my part. What I did instead is, I can kind of write out what I did. So deck of cards is our class, and we'll what's public, we'll just make it all public for now. I did a std array of class card, and then populated it with, they didn't care too much about syntax, which was nice. And then populated it with 52 items, and then the init I did was essentially void, which would be the constructor. This is really where I messed up, is this would be the constructor. Let me full screen this really quick. Yeah. What I should have done from the get-go is make this a constructor. So as a refresh, I'm going to go to the constructor just to get the syntax. Okay. So yeah, we'll have a deck of cards with nothing passed in, and the constructor for this will populate the member vector, which will, it will be private. The vector will be private itself, so we'll do std vector, and then let's go here for C++ vector syntax. So I mean, I get that part. Like, yes, we'll do this. We will take the, whoa. We will take this, put it above. Okay. So while we're up here, let's include, whoa! Let's include vector. Let's include string. And std, or iostream, not in C. Okay. So we'll do this. It'll be called deck. And we want to initialize this with 52 values. To do that, we either do this. I think we do this. And then this is where populate all 52 unique cards. So what I did in my logic in the interview was pretty much set up an iterate, like a manual iterator from I equals 1, because that's going to be our first value. And don't worry, I handle it in a second. I less than 13 is our condition, and our increment will be post. And here we will post. Yeah, I mean, we can use a post increment because it's getting called at the end of this loop. So essentially what I did is deck of I got hesitant using the vector because of pushback, and I'm not even using it here because I know the size. I know the size at the start, so I don't need pushback, which would push to what is it? It doubles capacity every time in a vector. If we are passing capacity in a std vector, what happens? More is needed is automatically expanded by the container. By how much? Maybe passing was the wrong word. Seeding. Automatically allocates a new larger memory. But by how much? Does it double? Like, I get it. We moved to a new memory location. But yeah, it seems really inefficient. I think if we allocate the space all at once, we're fine doing this. Anyways. Deck of I will equal our card item. Does it need a name? Let's say it doesn't need a name, just to play around with it at the start. So our first parameter will be I. Our second parameter is our suit. So this will be, for 1, this will be I minus 1. Want to start at 0 index. Card of I, our suit, let's start with clubs. The color is going to be black. And then we can do I. So let me think about this. This will be 0, 1, 2, 3. So we want this times 2 minus 1. We want this times 3 minus 1, and we want this times 4 minus 1. And then once this I goes to 2, well, let's first lay out. There is something wrong in that logic, and I'm worried about the state of my interview as a result. But it's okay. I was happy with the result overall. The rest of the interview, amazing, actually. Okay. So we have this. We want this to be 1 through 13. Which means that we would do, let's say this I think we can do this multiple ways, but if we really want this to be we need a second, I think we need a second incrementer if we're going to do it this way. But what we can do much easier is do, this is 0 through 12, this is 13 through 25, this is 26 through 38, and this is 39 through 51. Okay, now starting with this, we keep this as is, and we're fine. We keep, what we do here is do, we do I plus 12. For sanity, we'll do 13 minus 1. So that's easier to read. And then for the next set, we will do, we will do, okay, yeah, I did mess up the indexing, but he said he didn't really care about syntax. I was also given 15 minutes, so I'm not too worried, but so that'll go to 26 minus 1 is, yep, 25, and then we'll add 1 because I starts at 1. And then last one, we will do I plus 3 times 13 minus 1. Okay, so this will give our total indexing when it's constructed. Now, what I need to figure out is we will need to call this constructor again when all the cards are drawn. So yeah, there we go. So this is private. But I put this in the wrong spot. I'm realizing. We want this to be here because this is in our constructor. So we will then do this. And is anything else needed in the constructor? I don't think so. So maybe this is a good place to, I need to fix my spacing. Let me write down what to do. My spacing is wide here. Fix Vim spacing. Okay. So let's pause here for 1 second. Int main will make a deck of cards called deck. And then I guess we can also verify card of card equals one club black, and then we can stdc out the whole thing there, so we can do card dot value, we can do card dot suit, and we can do card dot color, std and l, return nil. Okay, let's compile and see where we're at. Ah, okay. Expected identifier before numeric constant. SD array in namespace std does not have a template type. Oh, I still have that in there? Oh yeah, let's take that out. We don't want that. Okay. Unresolved overloaded function. And in 28, yep, that would be useful. Okay, so that casting is incorrect. So can we just do this? Okay, invalid types, unresolved overload function of int. Oh, it's still having issues with this. This is how we learn. We don't read something and memorize it forever. We memorize after we do something tons of times. And this is, I might be wrong, but this is 100% better than going to chat and getting more than you asked for with a solution. Because then you just copy it right away and it's already in your head. This way, I'm actually thinking through the problem and what decisions I need to make moving forward when using these types of data, or these data types. Okay, list constructors. This is exactly what I want. So we will have to compile error direct. Yeah, this doesn't work. Oh, wait, hang on. This doesn't work because direct parentheses initialization is disallowed from member default initializers. Is that why we're having that issue? Interesting. I thought that would have been completely fine. So what we need to do instead is when providing a default initializer for a member of a class type, we must either copy initialization or list does not allow with the capacity of 8. Interesting. But can we also just do this? Constructor to construct a vector of length. My initializer list is non-empty. I see. Very interesting. So we have to do std vector of an int of 8. Int of 52. Cannot convert. Okay. Interesting. So if this was a normal type, this is fine. Yeah. Okay. Oh. So if we just, I thought it had to be an int because of the size. But if we just do this and change this typing to a card, then we're fine. Oh shit. Sorry, I didn't mean to say that. Also, as let's add a sanity here. So that we can actually see that we're doing this correctly. Let's start with deck dot. Oh wait, not deck dot. Deck of 0 dot suit. Nah. Let's go value. Oh wait, hang on. We can just grab this. Okay, I gotta figure out why Get Bash is doing that. I'm sure it's giving at least someone a medical condition proc. Okay. So we want this to be instead. We want our deck of 0 dot value. We want our deck of okay. No. Oh, we're in the thing. This doesn't work. It doesn't work in the class. How does that work? Okay, let's start simple. Let's do card. Well, okay, let's start here and see what we get. Club, okay. So that worked great. Let's now not initialize it. Well, okay. Instantiate. Let's do deck, or let's do, oh, damn it, why'd I delete that? Okay. So my thinking is the constructor should fire here. So then my thinking is we can do card equals deck dot what's the deck, might need to change that. Okay, let's see how this works. Yeah, I'm unsure what to do. Maybe we don't deal with the private nature just yet, and instead, upon let's just do this. Yep. Okay. So, this constructor, so actually, what we can do is for, how do we do it? I need to know how to do this. Auto, C in deck dot deck. We want to, we want our card I dig it. Let's do it. Okay. 0 through 12. That's not right. We have ace, 2, 3, all the way up to 10. Then we'd have jack. We're ending at queens. Am I already at an hour? My music stopped. Hang on one second. That's crazy. That was like... Alright, wait. I kinda want some like bumping music for a second. Definitely a different vibe. But we're in the groove, guys. We're like coding and shit. Okay. That's what we want. So we have our whole deck. Let's actually add into here a void for print deck. And we'll just snip this code. Whoa! We'll snip this code. Whoa! Okay. And then we're in our class, so we can just do this. Okay, and then we can just call out here deck.print deck. Yep. Alright. So now we have, it's fully initialized. Oh, you guys can't see. My bad. Alright. So I added this print deck function. I just took what I had just did as a sanity and put it into the class itself, so we can call it directly. What I think we want now, so our constructor is valid, but it's about to not be, because what we're going to be doing is, sorry, we're going to be having a function called draw that returns, so picks random valid index. How will it pop in the vector? So let's go down here, pop back. Pop specific index vector C++. Okay. So remove element at index 2. I kind of just want to run this example. So I'm going to tab new, an example vector erase, that's C++. So 10, 20, 30, 40, 50. And then we're deleting at index 2. So let's compile that. Okay, that's exactly what we want. And then we can keep track of, okay, yes, it's all coming together. So in draw, the first thing we want to check is, hey, how do we point back to the constructor? Do we... Okay, one thing at a time. If deck.size equals 0, or sorry, if it's, yeah, if it equals 0, then what I'm guessing we can just do is deck of cards constructor, and then we want to get a random index, which I'm assuming is going to be some sort of std random, and then our range is 0 through our deck.size. If our size is 2, subscript by 1. Okay. And then I will look that up because I don't fully know the random API. std random selecting random index. Okay, so first include, oh. Okay. really need to do all of that for the random? Okay. Weirdos. I guess we'll add it here. Because we could do it global, but I don't really want to do that global. That always scares me. Okay. RAM distribution. That's crazy. Okay. You know what? Like, Python maybe just made random seem really easy, but yep. And then our index API is distrib of gen. What's gen? Oh, it's up there. Okay. Okay. Now that we have our random index, we want to return. Ooh. Actually, we want to copy it over first. Yes, we want to copy it over first, so we want a card object, res, stands for result, deck of random index, and then we want to pop at that spot. So this will be an example erase. Cool. What's the for each? I'm confused. Okay, so we would do we know it's in valid bounds, so we would just do deck.erase deck.begin plus the random index. And then we'd return res. And then let's do okay. I have a plan here. We'll do a card equals deck.draw, and then we'll do this again. And then we'll also take this without all the tabs. Okay. Yeah, let's compile and see how this goes. Oh, that's the wrong compilation. Okay. RD is not a type. We might just want to put this in the global space. Okay. Okay, so we drew the 4 hearts red. And it's not there. So if we, to stress test this, we don't need this anymore. Okay. So what I'm trying to see is if we draw every card from the deck, we'll eventually have a size of 0. So I'm hoping that when that happens, we reconstruct. Okay. I think something's wrong here. So this looks random, but we might, let's do a few std cout. Interesting, so it's empty still. Maybe we need to assign it? Okay. Inside a function, inside a class, how would we call the constructor inside it? C++. So I think I'm beyond close here. I do want to see through chat. In the draw function, how do I recall the class constructor? Reconstruct the object in place. Oh, yes. Oh. The size is 0 when that last draw happens. So, we don't want that. What we do want is we can move. Whoa. So, okay. See, this is something to note. What did we learn that our gaps were here? We learned that, let's look at just a text file. Tab new, gaps. Vector semantics. Initialize size in class. Pop at index via erase. And another one I think would be that we didn't know what this pointer use case is. Okay. All right. See, this is what we learned from. I'm not too opposed to these issues, but we want to do this at the end. Bang. Bang. Okay, so this would have been the optimal answer. And this is essentially what I did in my interview, but we didn't really care about syntax. So like the random module is just kind of like std random, put in your index range, and then pass it in. But yeah, the resetting was there, and then calling init was there because I was using an array, but obviously I would use a constructor. And for code quality, you should definitely include a destructor, but I think overall this went fairly decent. So I'm gonna add this to my repo here, Apple Q1. All right, so I'm gonna leave there for now. Right at an hour. It's kind of where I wanted to be. Get an hour in the morning. I might record another one just to actually go into the C++, but I wanted to get some doing done rather than just note taking for an hour, and doing some like simple compile or no compile problems. So yeah, tune in again.